everyone. Right, I am Ollie, this is Mike. We both work at SimpleWeb, which is an agency in Bristol. You might have heard of it, and we'll tell you a bit about that in a sec. We're going to talk about a project that we worked on together called The Bridge, subtitled Reinventing Social Networks, because all we wanted to do was completely reinvent how social networks work in order to give more control and power to users. But we had 10 days, so we have another subtitle, which is Messing Around with Facebook, which is a more accurate strapline for what we spent our 10 days doing. So we had 10 days, and we settled for experimenting with and learning about crawling websites, scraping content, specifically from Facebook, and specifically creepy crawling Facebook, which is how I spent my morning. Those are if you've got better puns, please let me know. I'm genuinely interested. So we also learned a fair bit about WebSockets and about building a user-friendly CLI tool. And we thought some of what we learned in the process would be interesting to you. So we're going to talk a bit about the inspiration and the background behind what we did. Then we'll talk about and show you what we actually made. And then we'll go into some detail about how we did it and some of the gotchas and interesting things that you might want to use yourself.
Cool. So as Ollie's mentioned, we're both developers at SimpleWeb, which is an agency. And at SimpleWeb, we have a program we recently created about 6 months ago called Playground, which the intention of that is to, instead of working on projects for clients, that they give us an opportunity to pitch for our own projects, and then to pitch them to everyone, and then get a bit of time, a bit of resource available so we can actually work on these projects and stuff for us, essentially. So one week I decided to come up with an idea of pitching my own personal CRM, which would just be a basic tool that would allow you to manage every aspect of your life.
And that prompted for me the idea of not so much helping to manage every aspect of your life, which seemed a bit overly ambitious, but of managing your various social networks from one place. And I was trying to think of ideas to pitch when I read this in an interview with Antonio Garcia Martinez, who was a product manager at Facebook. Imagine if you somehow went back in time and tried to create a social network in the 90s or the 80s. You'd stipulate your own user-controlled social media file. That's something that I would own, and it would almost be like an email. I've got my data and I can shop it around to whatever social network I wanted, which is a bit cryptic, but I interpreted that to mean that I don't receive tweets or Facebook posts like I receive emails. So emails sent through any provider, and they reach me at some other provider because email is an open protocol. But tweets are sent and consumed and exist only in Twitter, and Facebook posts are sent and received and exist only in Facebook, which sounds kind of obvious when you say it like that. But then when you compare it with email, you think maybe it isn't completely inevitable. So rather than having all these totally separate networks, wouldn't it be more manageable to somehow bridge the gap between them? It might feel like taking back control from the separate gatekeepers of your social life. So this was one of our goals, to build something that could make social networks more connected.
Cool. So another goal of this was a quote from the same interview, actually, which is way before Facebook, going back to Google, they've always claimed, look, we're just intermediaries. The algorithm optimizes for a metric, whether it's engagement, clicks, or whatever. We're not responsible for what you see. At the end of the day, it's you, the users, for your actions. I think we're reaching a point where people are unwilling to write them that blank algorithmic check. So at that point, we thought, well, let's build something that's going to reduce the control of these algorithms so we can take control of what we consume on social networks. And in our view, these were pretty noble goals to be able to make loads of separate social networks more connected and just reduce the extent to which these algorithms control what we actually see. So ultimately, it was all about just giving control to users.
So we thought vaguely about some kind of new equivalent open protocol for social networks. So you might have a profile that any provider could subscribe to and any provider could publish to. So a Facebook user or a Twitter user could subscribe to your profile, so you wouldn't have to have separate Facebook or Twitter accounts to feed into those networks. And in turn, you would only need to subscribe to a user's single profile, which any provider could publish to. But why would Facebook or Twitter integrate with that protocol? And it kind of already exists. If you have a blog and you publish to an RSS feed, but no one uses RSS feeds, so you can broadcast your updates, but no one's listening, and no one else is broadcasting them, so that's not much of a network. So all of that was fun pub talk, but we had to come up with something we could build in 2 weeks.
Yeah, so in a sort of the classic agency way, that we had all these grand ideas and then we're told you have this amount of budget, this amount of time. So we decided one social network, one goal. So we decided to pick Facebook, and we decided to go with the goal of creating a Facebook newsfeed that would completely bypass the curated newsfeed algorithm that you see. So it would go to all of your friends, find all of their posts, none of the things they like or any of the adverts that you'd usually see, build a curated, or just one tool that would build a curated list of things in chronological order, compile them, and show them to you.
So we actually built a few things, an Express API that runs on your machine using your Facebook credentials. It has a JSON endpoint that does a lookup of your friends' posts, since a given timestamp, then returns them. And it also has a WebSocket endpoint that does repeated lookups and sends back posts as and when it gets them. We also built a React front end to consume that WebSocket endpoint, and a CLI tool to help the user get their Facebook credentials in the right place on their machine and spin up the Express API and the React app. And now's the magical moment of trying to demo it. Ooh. So this is the little CLI tool, which is starting our API and the React app. Let's see. You'll see we didn't spend much time on the front end.
We're back-end developers, that's all right.
I should probably say we're not JavaScript developers either. Anyway, right. So this is our front end. So I've already put my credentials into the relevant place on this machine. So when I start, I'm going to connect to a Facebook account I set up specifically for this, who has one friend. So it's done a first lookup, but sadly that friend hasn't posted in the last 2 hours, so nothing came up. So this is the friend. So something like that. So in theory and in all our practice is when the API does its next lookup, it will find that post and display it for us. And in the meantime,
Yep, so ultimately the vision that we had for this is that we're working on one social network, one goal at the moment, but ultimately you'd be able to pull in content from any social network. So there might be certain social networks that are a bit easier to crawl and might have APIs that are open enough you can just grab whatever you want.
hooray!
Oh, brilliant.
So that is the magic and slightly underwhelming demo. How did we do that? We're going to focus on the scraping and the creepy crawling part of the tool. But for the WebSockets, we'd recommend the WS library for creating a WebSocket endpoint server-side, and we use Socket in the React client to consume the WebSocket endpoint. They worked really well. For the CLI, we used Meow to create that beautiful the bridge that you saw. We used Inquirer for setting up the end file with command line prompts, and concurrently to get the two processes running in the same command line output.
Well, and the meat of what we've created is the crawling. So for the crawling, we used a tool called Simple Crawler. I suppose a lot of you are wondering why crawl in the first place when Facebook has their own perfectly adequate APIs. But from what we've experienced, that they don't really give you the access you need. It can be a massive pain to get it set up. It goes against the idea of having a curated feed because you're getting directly from them, and mainly just because we're developers and we thought let's scrape it.
So some code. How does Simple Crawler work? How did we get it working in our API? So this is the full JSON endpoint that triggers a single lookup of your friend's posts. So you have a crawl helper that sets up configuration for the crawler itself, including the starting page that the crawler is going to visit first. Luckily, Facebook still maintains a completely JavaScript-free website, which is mbasic.facebook.com. So the crawler had no problem at all visiting that, and it's fully functional. The crawler works by loading that initial page, finding links on that page, visiting those links, then finding links on each new page, and so on recursively. But we only wanted to visit certain links. We wanted to visit lists of friends, those friends' profiles, which show their recent posts, and next pages of posts if the current page didn't go back far enough. And it also turns out that when you visit a friend's profile, you actually go to an intermediary page called a hover card, which then has the link to their post. So we had to include hover cards as well. So the first task was to get the crawler only to visit the correct pages.
Yeah, so we managed to do this through what's called in a Simple Crawler land a fetch condition. So we use the add fetch condition function and essentially just tell the crawler that only put a link in there if it's either a hover card, which is when you, on normal Facebook, when you mouse over someone's name, you get the little cards. That's an actual page within MBasic. The profile page itself, whether you're on the list of friends or whether you're on the list of their posts, because you're going through with no Ajaxy magic going on, you're manually loading each separate post. So what this would essentially do is taking the queue item, which is for all intents and purposes just a link, and just compare it against these to say if it matches these conditions, and if it does, it can go on the queue. So you could probably notice that on the load more friends, there's quite a bit more going on there than the rest of them, and that was because we initially started using this on our Facebook accounts, and when you get to a certain number of friends, not to say that we've got loads of friends because we don't, but when you get to a certain number of friends, it has to go through all of those friends, and we were sat there waiting, just like, come on, hurry up. So we put a bit of limiting in there. So what we've set up is a crawl tracker to essentially go through a list of 10 friends. So we go through, say, a list of like 3 lists, so go through 30 friends and just limit it in that way. So going on to the events for Simple Crawler, it gives you quite a lot of events out of the box, which gives you pretty much limitless flexibility for what you might want to do in terms of crawling. So if you wanted to track, say, how many friends you visited, you use the queue adds event, and that would just build up on the queue tracker, which was just an instance of a class that adds 10. To say once you've gone through the list, track 10 on there. Anytime you run loaded more friends.
So that was how we got to the correct pages. The other complication is that we didn't want to continually load more posts. We only wanted to go back enough to make sure we were getting all posts sent since a get post since timestamp. And this couldn't be handled by checking the queue item because it depended not on the link of the page but on the actual content on the current page, specifically the timestamp of the oldest post on that page. So for that we tapped into the crawler's discover resources function, which does have access to the current page. So what this is doing is ignoring links on the page. If we're on a page of posts and the oldest post on that page is older than the get post since timestamp. So it's just another example of the flexibility that Simple Crawler gives you through the events and functions that are accessible.
Cool, so you've gone through all these processes, you've gone through all your fetching, so you eventually get to the fetch complete event. So once we've got to this point, we've got our buffer of what we've put into our queue. So we need to actually get the HTML content out of that. So we created a basic HTML helper object, which we'd use to bring the buffer in there, get any of the articles we need, get their names, get the posts, and then anything we need to filter out if it's too old or too new based on the last time you've crawled would get put into the current crawl. Ooh, nearly dropped it all. Cool. So. From here, you can see we tried to extract as much of the logic as possible into this HTML helper. We used an NPM, we used a library called Cheerio, which for those who still yearn for the days of jQuery, it's a jQuery type accessor to the DOM, which is nice for me in my old days of JavaScript. Not so much from now. But, so you can see there are the key functions of it to see how we've actually gone and parsed some of these. And I think if you can see the code, you can see it's not the nicest way we've had to go and get some of these things because the actual markup you get on the MBasic site is pretty poor at best. So it's a bit fiddly and a bit brittle, but it works for now.
For example, there's not a class name for article to get or post to get a post. So the most sort of reliable way we found was finding the like and React sort of interaction bits that are on each article or each post and traversing the parent of that to get to the post. So it's worked. Well, we did this in a few months ago, and when we spun it up last week, it still works. So the markup hasn't changed enough to break it, but it is still pretty brittle.
Yeah, MBasic hasn't changed in 5 years, so I hope it doesn't change.
So,
no.
But all of what we've talked about rested on being able to get the crawler to act as a signed-in Facebook user, and that was the trickiest thing that we had to crack. So we used an HTTP library, request promise native, to load a Facebook login page. Then we got from that page the values from any hidden fields that were on the page that Facebook populates to prevent cross-site request forgery. Then again, using the HTTP library, request library, we submitted a login request using those hidden fields as well as the user's credentials, and that gave us the response for a logged in user, including the cookies that Facebook adds to authenticate further requests. So that's just going to the login screen, and then this is submitting the actual login request. The first difficulty we had was around here. Facebook doesn't always respond when you log in with a nice 200 response. Often, actually, normally it redirects you somewhere with a 302 response, and our library was treating that as an error. So we had to just swallow that error here. And then the next challenge was getting the session cookie from the Facebook response into the crawler. The Simple Crawler actually has its own cookie jar and an API for getting cookies into that cookie jar from headers. But unfortunately, Simple Crawler was then ignoring those cookies when making requests to Facebook, ignoring the cookies that it had in its cookie jar. It took a while to debug this, but Simple Crawler ignores cookies if a domain being crawled, so in this case mbasic.facebook.com, is not contained in the domain on the cookies in question, in this case facebook.com. So we tried to get Simple Crawler to fix that, but the issue we logged fell on deaf ears, and so we just fixed it ourselves with a little thing here which just replaces the domain on the cookies that we get back from Facebook, so they have the domain that Simple Crawler needs. And hooray, once we did that, we were able to act as a Facebook logged in Facebook user with any requests that the crawler was making. So just once again, this is the full JSON endpoint, which maybe makes a little bit more sense now. We're setting up the crawler, we log in as the Facebook user, we start the crawler off, and then when it finishes doing its full crawl, we return the post that it has found in the process.
Cool. So from what we've shown you, I think clearly this isn't going to change the world. We're not going to have Mark Zuckerberg knocking at our doors with a lawsuit in his hands. But in like one of the major problems we found with this was naturally actually crawling the data, just trying to get through the markup, what was there, and just actually trying to get the stuff that we actually wanted out of it. But we've managed to rinse the limit of our 10 days quite nicely. We weren't really sure we were going to actually be able to succeed with this, but within 10 days we persevered and we managed to get a working demo out of it and working tool that you can download.
So the code is here, it's open source, and you're very welcome to, and with full instructions on how to use it, and you're very welcome to go and have a poke around and let us know what you think, and by all means submit pull requests and issues. Thank you very much.